Motivation is fundamental to our daily life. It's what allows us to get out of bed in the morning. It's what allows us to pursue long-term goals or short-term goals. Motivation and the chemistry of motivation is tightly wound in with the neurochemistry of movement. In fact, the same single molecule, dopamine, is responsible for our sense of motivation and for movement. Even though nerves controlling muscles, so again, these are nerves in the spinal cord or brain that move our limbs, the effector chemical there, the one that actually causes the muscles to twitch, to contract, is acetylcholine. In the brain, acetylcholine is responsible for focus. However, whether or not we move, whether or not we want to move, whether or not we have the desire to overcome barriers of, they could be social barriers or financial barriers or time constraints, that depends on this molecule we call dopamine. It's a fascinating molecule, and it lies at the center of so many great things in life, and it lies at the center of so many terrible aspects of life, namely addiction and certain forms of mental disease. So if ever there was a double-edged blade in the world of neuroscience, it's dopamine. So let's talk about what dopamine is. And as always, we are going to talk about actionable tools. Today, we're definitely going to talk about some things related to supplementation, although you might be surprised to learn that it's not all just about increasing dopamine. And in particular, in some cases, that's the wrong thing to do. Sometimes it's appropriate, sometimes it's not. More so, we're going to talk about tools related to what's called dopamine scheduling, how the way that you're leading your life and the way that you're conceptualizing your goals can actually predict whether or not you're going to continue to pursue those goals, and therefore whether or not you will succeed in achieving those goals, as well as whether or not you will quit. There's a fundamental relationship between dopamine released in your brain and your desire to exert effort. And you can actually control the schedule of dopamine release, but it requires the appropriate knowledge. This is one of those cases where understanding the way the dopamine system works will allow you to leverage it to your benefit. And if you don't understand the way that dopamine works, there's a good chance that it's going to pull you out into the current of life, meaning the rest of the world is going to control your dopamine schedules. So I'm excited to tell you about today's information. You're going to learn some basic science. You're going to learn a lot of tools. And these tools, I believe, are applicable whether or not you're 5 years old, 8 years old, 80 years old, or anything in between. So let's talk about dopamine. Let's get a few basic facts on the table. Dopamine was discovered in the late 1950s, and it was discovered as the precursor, meaning the thing from which epinephrine or adrenaline is made. Now that's fundamentally important because this molecule we call dopamine, nowadays we think of as the molecule of reward and pleasure, but actually it is the substrate from which adrenaline is made. And in the brain, it's the substrate from which epinephrine is made. Epinephrine is the same thing as adrenaline, except in the brain we call it epinephrine. Epinephrine allows us to get into action. It stimulates changes in the blood vessels, in the heart, in the organs and tissues of the body that bias us for movement. Dopamine was initially thought to be just the building block for epinephrine, and it is indeed the chemical building block from which epinephrine is made. However, dopamine does a lot of things on its own. It's not always converted to epinephrine. Dopamine is released from several sites in the brain and body, but perhaps the most important one for today's discussion about motivation and reward is something that's sometimes just called the reward pathway. For the aficionados, it's sometimes called the mesolimbic reward pathway. But it's fundamentally important to your desire to engage in action, and it's fundamentally important for people getting addicted to substances or behaviors. So how does this work? Well, you've got a structure in the deep part of your brain called the VTA. It stands for ventral tegmental area. The VTA, or ventral tegmental area, contains neurons that send what we call axons, little wires that spit out dopamine at a different structure called the nucleus accumbens. And those two structures, VTA and nucleus accumbens, form really the core machinery of the reward pathway and the pathway that controls your motivation for anything. You can think of them like an accelerator. They bias you for action. However, within the reward pathway, there's also a brake. The brake or restriction on that dopamine, which controls when it's released and how much it's released, is the prefrontal cortex. The prefrontal cortex is the neural real estate right behind your forehead, It's discussed for so many aspects of neuroscience. You hear about it for decision making, executive function, for planning, etc. And indeed, it's responsible for a lot of those. It's this really unique real estate that we were all endowed with as humans. Other animals don't have much of it. We have a lot of it. And that prefrontal cortex acts as a brake on the dopamine system. Without that brake, you would be purely a pleasure-seeking animal.